Hello, I'm Oskari Vainio, and in this video I will present Dekati solutions for breakware particle emission measurements. Dekati is located in Finland, and we have over 25 years of experience in development, manufacturing and sales of fine particle measurement and sampling solutions. Our product range consists of real-time instruments, impactors and sample conditioning devices. All Dekati instruments are manufactured, calibrated and tested in Finland. Traffic-related particle emissions consist of exhaust and non-exhaust emissions. Both categories have roughly equal total particle emissions. According to studies, breakware emissions account for up to about 50% of the non-exhaust emissions in urban areas. There are three important aspects in breakware particle emissions: wide particle size range, transient events, and complex mixture of materials. Wide particle size range is caused by different particle formation mechanisms involved in break events. Friction causes mechanical wear which emits large particles, also known as the coarse mode. When the break components get heated, the high temperature break events emit smaller particles down to just few nanometers. This is called the nucleation mode. As these tiny primary particles coagulate, agglomerate and grow by condensation, the accumulation mode appears. All these three modes can be observed in the breakware particle emissions. Breakware emissions are usually measured over transient drive cycles. In order to look into the break events, fast response and real-time measurements are needed. The third aspect is the broad spectrum of materials that applies especially to the ingredients of brake pads. Because of this, it is often useful to analyze the collected particle samples and see what's the chemical and physical composition of the particles in each size range. Additionally, it's beneficial if the instrument response is not affected by the optical properties of the material, for example the color, which is the case for some optical instruments. For breakware particle emission research, I would like to highlight the Dekati LP+, which is a widely used and recognized aerosol research instrument. It's the only real-time measurement instrument that can cover the whole wide size range, including nucleation, accumulation and coarse modes, without the need to use multiple instruments and different operating principles. It has a fast response and gives the size distribution in real time without long scanning periods. With analysis plates, the sample is also collected on substrates in 14 size fractions, giving the possibility to do both analysis, for example electron microscopy and chemical analysis. These benefits are achieved by combining the electrical measurement with a Cascade impactor. When the sample enters the instrument, it meets the charger. In the charger, the particles flow through a flux of positive ions. After this, the sample enters the impactor, which size classifies the particles according to their aerodynamic size by inertia. Electrometers are connected to each electrically insulated impactor stage to measure the current caused by the charged particles. The outcome is a real-time size distribution in 14 size fractions, or with the high-resolution LP+, in 100 or 500 size fractions. Optical properties of the material do not have any effect on the results. The size-classified particles are collected on analysis collection plates on aluminum or polycarbonate foils and can be analyzed further. In case post-analysis is not needed, the sintered metal collection plates can be used to significantly increase the maximum loading. We have tested the sintered plates in long-term ambient air measurements, and the instrument passed our reference test even after 6 months of constant sampling without any cleaning of the instrument in between. In breakware emission measurements, the sample is usually drawn from a rake dyno or some other enclosure. The basic idea is to feed particle-free air through the brake system. After it has flown past the brake chamber, it carries the breakware particle emissions to an outlet duct. To ensure a representative particle sample, an isokinetic nozzle is used to draw the sample to the particle measurement instrument, which is connected to a vacuum pump. Dekati can provide you the whole setup from the nozzle to the pump. Here are some examples of breakware emission datasets. For more information on breakware emission measurements, please visit our website and YouTube channel. In YouTube, you can find our 1-hour webinar recording on breakware measurements. Most importantly, please don't hesitate to contact us. Together we can find the best solution for your particle measurement needs. Thank you for watching this video.